Have you ever seen how kabadis weigh your old newspapers? They will take a weight of say 1 kilogram on one side and put 15 or 16 newspapers. When it is balanced, then what they do? They remove the weight and they put those newspapers that they had weighed on one side, and then with the help of that paper only they keep kind of weighing the other papers, the piles of other papers. Or say you take the case of watermelon. If say your watermelon is 10 kilograms and you make 10 slices out of this. So more or less each slice will weigh 1 kilogram. So if you want to sell 1 kilogram and you don't have the weight of 1 kilogram, what will you do? You will just take that one slice and keep weighing with it. Though of course this will not be an exact measurement. Now how do atoms exist? So small, so tiny, can they exist on their own? Some of them can, but not all. Many of the atoms, they combine together to form a molecule or an ion. So now we have to also understand what is a molecule and what is an ion. Now when two or more atoms combine with each other, what they form is a molecule. And a molecule, unlike atoms, can exist independently. So we can define molecule as the smallest particle Now atom is also smallest. Why I am saying again smallest? That can exist independently. In some cases, an element can exist as one atom only. It is called monoatomic. Example, iron. So one molecule is just one atom. In some cases, like especially gases, it is diatomic. That means two atoms combine to form one molecule, like O2, H2, N2, Cl2, etc. In another case, say what happens when three atoms of oxygen combine? They form ozone. So that is triatomic. In the case of phosphorus, the molecule is made up of 4 atoms. So it is tetraatomic. And in the case of sulfur, there are 8 atoms. This is called polyatomic. Poly means many. So depending upon the number of atoms, their name is mono, di, tri, etc. Now when we want to express how many atoms are there in one molecule of an element or a compound, we use a term which is atmosity. So atmosity is number of atoms in one molecule of an element or compound. So we can say that atmosity of oxygen is 2, and in case of ammonia, atmosity of nitrogen is 1 and that of hydrogen is 3. In case of nitric acid, atmosity of hydrogen is 1, nitrogen is also 1, but oxygen is 3.